Good afternoon, everyone. Welcome to the seventh seminar on best practice in teaching and learning of the Lorena School of Engineering of São Paulo. I'm Professor Valdeir Hernandes from the University of São Paulo, and I'll be moderating this section. At this moment, I would like to welcome Professor Angeli, who will be presenting a talk titled Engineering Your Students' Learning, Orchestrating Action in the Classroom and Beyond to Meet Educational Goals. Dr. Angeli Steen is faculty member, as a faculty director at the MIT General World Education Lab, associated dean for open learning, and senior lecturer at the MIT Sloan School of Management. Professor Angeli, on behalf of the event coordination team, Professor Ellen Andrade and Professor Elisângela Moraes, we would like to welcome you to this event. And we would like to thank you for kindly accepting the invitation to join us today. To all of you participating with us, I suggest you to note your questions and observations you would like to discuss with Professor Angeli at the end of the lecture. Please post the questions in the chat. Your participation is very important. I now pass the floor to Professor Angeli and wish everyone an excellent lecture.
Thank you so much. I
Professor
am
Angeli.
really excited to be here. Can you hear me okay? Yeah? Is the sound working? Yes. You'll let me know if it isn't. Okay, all good. So, I have known and loved working with faculty from across USP, and I've had many amazing Brazilian students over the years. And I'm really excited to get a chance to frame what I think is a really important discussion about how we orchestrate student learning. So it's one thing to focus on instruction and sort of didactic approaches, but what about the challenging art of enabling the learning to emerge from experience? That's what I want to explore with you today. And I was doing a play on words for the title, as you see. So engineering learning, you can learn about engineering but also we're talking about engineering the act of learning through this construct of orchestration. So we'll go into that, but first I thought I would take just a few minutes to tell you a bit more about myself and how I got to this point and how I've gleaned this knowledge. I am a product of MIT. I actually don't have an engineering degree, but I have a physics degree and a humanities degree and a social sciences PhD. And I have worked with and taught engineers for decades. And one of the great joys of teaching here is that I get to teach students from many disciplines in my classes. I also work at MIT Open Learning, where I'm faculty director of the Jameel World Education Lab. And our job is to scout for ideas and practices from MIT and from the whole world, from our members, to bring to bear on common challenges in education and to spark transformation by sharing ideas, co-creating new ideas and plans, and generally kind of orchestrating at a global level faculty to faculty conversations. So USP is a member of the Jameel World Education Lab, and we definitely want you to join us and come to the talks that are very much targeting faculty. This morning we had a talk on the work that MIT is doing on sustainability and climate change. And all of these are recorded. So if you activate your membership, you'll be able to go and look at this morning's talk, yesterday's talk on AI, and I gave a talk on Tuesday on innovation pipelines, academic innovation pipelines. That's just a plug for JWell, which I'll come back to later. So JWell also afforded me the chance to put my head up from the teaching and step back and ask, what are we learning about how students learn that we most want to bring to everyone's attention and discuss? So that's what today's focus will be. Good? Okay. So first, I went to the ABET website, and different accreditation approaches might look a little bit different, but this is probably pretty common. So this is an accreditation agency that focuses on science and engineering programs, I should say. It also includes some technology and science. And interestingly, they actually put program educational objectives before student outcomes. Faculty very often look at student outcomes and ask, what should the students know or do by the end of the class or by the time of graduation? ABET is asking us to also look ahead to where will the students be a few years after graduation. What do you expect them to do then? And it's pushing for the student outcomes to actually speak to that. It's a useful construct because it gets you towards thinking of real world application rather than classroom-based or assignment-based outcomes. And just if you want to see a deeper definition of program educational objectives, they are broad statements. They actually should reflect not only what you, the faculty, feel and your chairs or your academic governance system, but also alums, industry, governments, employers. It should reflect a broad sense of what is important for such a person to be able to do. And they're rather broad. And in engineering, you're always, I'm sure you experience this, you're always going to see elements in there related to communication, to teamwork, to leadership. And fitting those in and grounding them in engineering is, I think, a really fascinating challenge. Okay, this just a couple more definitional things, and this one's a bit detailed, but I'm sharing when I share the deck, you'll be able to see the link. But I thought I want to call out a few of the interesting aspects of this particular definition. So this is saying, okay, what are the student outcomes that matter? And there's a couple of words I wanted to flag. One is the ability to identify, formulate, and solve complex engineering problems. Like that's one of the buzzwords, right? And then the second one, and by applying principles of engineering, science, and mathematics. The second one to call out is the ability to apply engineering design to produce solutions that meet certain needs. And then to think about the many criteria and factors that shape a solution: health, safety, welfare, economics, environmental, global, cultural. And then the ones that maybe that enable those that include communication skills, teamwork, experimentation. The sort of core disciplinary stuff is at the bottom: experimentation, analyze and interpret data, use judgment, and acquire and apply new knowledge. And it also puts in there as number 4, ethical and professional responsibilities. So many of these topics, if you think of ethical and professional responsibilities, if you think of engineering design, if you think of complex engineering problems, they are begging to be developed and applied in a practical sense. So that's where I'm going with the orchestration of learning idea. You can study these things through traditional assignments and case studies, but what do we get when we push for a link to action? We'll get there in a moment. And these are the definitions. I'm not going to belabor them. You kind of already, I'm sure, all know, have your own definition of a complex engineering problem. And engineering design, they just threw everything in here. It's like everything you could ever want to care about as an engineer. But sure, why not? We want to understand trade-offs. We want to understand it's deeply iterative, and it's creative, and it's also interactive. So this is throwing, every aspect of good professional practice into into this sort of bucket of engineering design. But it's very useful to have definitions and focus areas like this to advance your own conversations on campus with your colleagues and your students. How are you defining this? How are you seeing your own classes, your colleagues' classes playing out, with respect to such definitions? Are your students getting it? Do they see this in their learning experience? So fine. As I was sort of just suggesting, these definitions give us a baseline idea that we can take from either our a published papers or a standards organization like ABET or other sources. But then we also need a model of learning. And over the years, as you go through life, you sometimes figure out it's actually better to simplify and to pare things back. And I spent a lot of the last couple of decades really trying to think about how to embed a very simple learning loop into everything we do with our students. So we've actually been applying it at the level of, when we do orientation for students, when we help them to realize, yes, you're taking a class that maybe seems very technical or very construct based, but look, next semester you're going to apply it, and we're going to be expecting you to link the two and figure out what works and what doesn't. So even if within a given class you can't do all these things, it's become both a superstructure for us to get our students, have a more explicit conversation with our students about learning. And then it also informs the design of specific learning experiences. And we've tweaked the language a bit over the years, but this version has prepare, act, reflect. Of course, this is not new. This is the OODA loop. This is Deming. There are lots and lots of learning theorists who have the same point. But I think what might be interesting to consider is the effort, the activity we did to actually surface this and make it explicit with all of our students. Because I feel like if you do that a bit, it makes it possible for you to expect some of the connections that otherwise are tacitly expected. And we can dig into that more later. So why is this tough? Like we have those, beautiful kind of challenge statements or ideas coming from ABET. We have this really simple prepare, act, reflect. Why is it tough to extract learning by having students do cool stuff? And I thought I'd lay out a few ideas from the literature and then show you a few examples. So that's where we're going with the rest of today. Okay, I don't know if any of you have read this piece by Chris Argyris, but it's a brilliant title because you can give it to anybody and they feel flattered because it says, teaching smart people how to learn. So you're kind of telling them, you're smart, but you're not really learning. And it's a good article that way. It's focused on a business situation, but I've used it a lot, and I've used it with fellow faculty as well. So why is it hard to learn? I teach a lot of professional, like MBA and advanced professional learners, as well as undergrads. So for sure, item 2 comes into play a lot. So smart people don't fail often. They haven't built capability, muscle, routines, processes for learning from failure. Professionals often have a set body of knowledge that itself provides the lens and the constraints of self sense making that impair learning. And then we have these very human capabilities, habits of defensive reasoning, which happens and is not, there's often not a counterweight to it. So especially in the workplace, so there somebody's challenged, it's acceptable to kind of focus attention away and not engage in the thing that's been brought to you as a challenge. Because if you do take on that challenge, one risk is this sort of self-reinforcing despair loop. And I've seen that with students too. Get onto a track where things are not going great, and then they start to say, I'm terrible, I can't do anything, and so on. All right, we don't need to go through this whole thing, but let me point to the last one. Arjus is saying smart people to learn should identify the inconsistencies between espoused and actual theories of action. Okay, that's fancy language, but it actually relates to every basic core kind of educational theory as well. That learning happens when we're a little bit surprised, when there's a mismatch between what we thought and what we see. And the art of orchestrating really effective, engaged learning with projects and experience and real world application is to orchestrate, help pull out those surprises and make sure they are scaled to the right size. Too little, and the students can ignore it or write it off. Too big, and everything collapses, and it's too hard for them to get back some focus and get on their feet. The right scale surprise inconsistency can trigger the learning that is so needed. We'll dig into that in a couple of different ways next. Okay, don't read this. This is actually a list that's behind, I was actually looking for the graphic and I couldn't find it, like one of my all-time favorite infographics. But this is just to let you know, we have a mega list of errors of judgment, ways where our natural way of looking at the world leads us to draw the wrong conclusions. And it's not here to say, we can get rid of them or any of those things. I'm putting it here to say that structuring learning, we don't always naturally learn from our own experience because of some of these errors. So your job as a professor is to help folks. Sometimes you want to help them by making them aware of this, but even just your being aware and then designing the interaction or the assignment to help them counteract these biases or to see them, that can be incredibly useful. So not enough work has been done, to my mind, in figuring out how to better link our growing knowledge of errors and biases of judgment to effective, practical, applied teaching practices. But for me, knowing some of these things exist, I use them. I certainly use positive outcome bias and the self-image and sort of the need to look good in your own mind and in others that can really affect learning from experience, et cetera, et cetera. Okay, we won't dig into these, but... And then one last point. This is from Robin Dawes. It's a little old, but put so nicely, the Carnegie Mellon. This really rings true to my experience, although perhaps my method of feeling that is also evidence of the same flaw that Dawes is pointing out. Because in life, even when we act professionally, we tend to look at what happened and then find a cause. We don't live life as actual scientists. We actually notice certain things and don't notice others, and then we link them to something else we notice or see. So we're treating these inferences as if they are data, but as Dawes calls it, bogus. And it's bogus because there are no comparisons, right? So there's no control case. And it's not mentioned here, but sort of bias in selecting the things you're looking at clearly comes into play. And then we're relying on memory. So retrospect is very famously flawed and limited. And often you hear people saying, you know, my professional experience. But yes, so you might have accumulated many such moments, but it doesn't mean they're bias free, right? You may have a whole stack of these cause effect stories in your head. Not necessarily the case that they're correct. So what should we do? Sure, we should all live like actual scientists, right? Begin with hypothesized antecedents, allow the consequences to occur as they will, and then track what happens, track those linkages. Now, that's pretty hard to do in real life, but great news. As a faculty member, you can do this a bit more. So this is your chance to help embed a way of thinking. And maybe even if we we naturally tend to the things that Dawes is criticizing here, getting your students to understand this trap could be really, really useful for them throughout their career. So that's my pitch for taking seriously the poor inferencing that we sort of natively do. Oh, yeah, this is one. This one is not a bad quote. It's about children, but it's sort of underscoring the value of doing things that are challenging and unknown. And this is a bit of an old piece, but it just sort of makes the case that, which I'm sure, again, you all have seen and know in some way or the other. But a true test of intelligence is not how much we know, how to do and what to do, but how we behave when we don't know what to do. And to actually cultivate, per Holt's view, intelligence, you need to open yourself up to the new situation. You need to look at all the signals. You need to think about it. You need to wrestle with it boldly, not timidly, not just in a perfunctory way, and be confident or hopeful, and then look without shame or fear at your mistakes. This gives us a pretty good goal set for the learning experience we want from our students that could then address some of those opening ideas I laid out for you. If we want students to engineering design or to understand addressing complex challenges, we need to create learning experiences that hit these criteria and then make it a little visible to them so that they actually grasp it and move with these ideas through their lives. That's the goal. Okay, but this is all heavy, right? And when I started thinking about learning, I also read about children's learning. Really, really interesting. So I wrote down everything Harry said when he was 5 in one day. Why can't I fly? Why do I have to go to Zachary's house? Why can't I use the computer? Anyone who has kids knows these questions. Why can't I use the computer right now? Why do you sweat? Why can't I have chocolate for breakfast? Can I be the only person who can fly? Or could you fly when you were a little girl? Okay, Harry is now 24. What do you think he is? He's a pilot. He went to Embry-Riddle Aeronautical and Astronautical University. It was like the place for him. And yes, he loves airplanes. He loves flying. And you can see it at 5. That's pretty cool. But for Harry, it was his questions even. There's like a little bit of fun, joy, engagement, even obsession at work in his interaction with the world. And I think we need to think about those elements in a real world learning experience. In particular, we know that especially for adults and old like youth, that the learning experience is really enriched when there's meaning attached to it. Famously, adult education researchers have found that adults need that sort of application linkage or so what linkage that little kids don't always need. But setting aside that issue, just the caring about what happens, we know drives willingness to engage in complex challenges. So another aspect of designing a complex challenge assignment or project for your students is thinking about what is meaningful to them. How will I get them to like pull out all the stops in engaging in the learning experience instead of just trying to get through the steps? And meaning and relevance and passion, I have discovered, really matter. And the research agrees. Okay, I have 3 examples from MIT, but I'm going to only present you with one. But I don't know if you knew this, but this is one of my favorite facts about MIT. So MIT was founded in 1861. And by the turn of the next century, early 1900s, 1904, 5, we had a chemical engineering department. MIT built an entire effort that continues today called Practice School. And Chemi Practice School was a really interesting idea. MIT sent its own personnel to go and be embedded and live inside chemical plants in companies around the US. So we had seconded an MIT employee to sit full time in these different chemical production plants or research labs. And their job was to bring the issues back to campus, but also to orchestrate and structure juicy problems that were real to industry and that were something that an MIT student could work on, like that were calibrated appropriately. And we still do this. So that's a pretty amazing legacy. It's, of course, rather expensive because you have to think about this whole staffing thing. And I'll tell you about some other ways in which we've driven down costs of such real world engagement. One of my favorite programs across MIT is the Leaders for Global Operations. It's a dual degree program where master's students get an engineering degree and a management degree. But the LGO manages to deliver a really solid learning experience they work with industry over the years. So company will be a member of LGO for multiple years. I work, for instance, with Novartis and Boeing students. So let's say Novartis, the pharma company, has a relationship with LGO, and every year they will submit a problem, and that problem becomes, one of the students chooses to do it as their thesis, and they are embedded at that company. But at the same time, the faculty running it go and visit them. There's a huge amount of interaction. the Novartis folks come to MIT as well to see the presentation. So it's not simply an internship or an externship. It's really tightly coupled to what they're being taught. There's sort of an on-demand sequence of materials that are taught to the students when they're in the middle of their 6-month intensive thesis experience. And we see programs like that playing out with doctorates, that more practical doctorate type degrees that are not PhDs. I think figuring out how to structure these and make them cost effective and make them rigorous and ensure that the students not sort of off on their own, but they're constantly linking what they're doing to the curriculum they're learning and reflecting on it. That's, I think, a really, really interesting but important part of how to get this right. Okay, I am going to talk about one example that's my own, and then we'll have plenty of time for discussion. So under this really general heading of action learning and action learning labs, because we're MIT, everything's a lab, I created a program that I call Global Health Lab. Those are some of my students in the field in Tanzania, working with the doctor there. And Global Health Lab, I wanted to push students' ability to tackle complex challenges and do so in a domain where they were not experts. I'm teaching MBAs and engineers and scientists to some extent. They are not going to be experts in healthcare. So they have to listen and they have to collaborate. On the other hand, when I set this up, it was 2007. Students were really, really interested in global health, and we had no courses anywhere else at MIT on that topic. So I attracted tons of students, and I could then afford to expect a lot of them, because I would say, you are lucky you got into my class. To all the students who didn't get in, it's observable that they didn't get in and you did. So you better do a good job. So I could actually increase my expectations through various emotional and other methods that I think, because I was testing for this motivation idea. Like, can I really trigger them to feel extra motivated? And will that lead to better learning, right? That was my big, really important question I wanted to understand. It took me a while, but I thought I would show you a little bit about how I structured this work, because my students are there in Africa. How is this all fitting together? So, oh yeah, there's a whole bunch of articles. Funnily, it actually attracted a lot of press reports, some of which were really effective in conveying the teaching philosophy. I was very grateful for that. The one on the bottom, which I couldn't pull out, does that, I think, better. The one on the top is good too. But anyway, okay, here's how I did it. So this is a panel of 4 images that I would share with the world. So I would say, are you a doctor, or do you run a clinic, or do you have a healthcare startup or a device company somewhere in a low resource setting? Then come and talk to us with a problem in mind. So problem formulation is usually step 1 in real world projects and project-based learning. I have learned over time, it's never a one-shot deal. You always have to iterate. So I do the first few iterations directly with the collaborators, because I don't want to throw my students into a massive mess. I want to frame it a little, because I also want my classroom teaching to fit with the problems. So I can shape the problem statement to align with learning goals and classroom content and deliver value to the partner. Then the students actually typically spent 3 months. It depended on how I taught it, but usually 3 months working remotely to collaborate on potential solutions. So they're getting data And then they're coming up with ideas, and they're doing desk research and field research here or whatever. Like they're getting there. It's just as important as being there is being prepared and reflecting after. Prepare, act, reflect. So then they go there, and usually they would spend a month living and working in the same place with the employees of the clinic or the facility or the company. And the whole goal that I moved towards was, don't do a study, do a very small something practical that you think might solve a real problem, even if it's a tiny version of it, and measure it right away, and teach people and figure out what the next steps would be. And then come back and spend some serious time reflecting and then talking with your hosts and with me and the rest of the class to really pull out what you learned. It was the most fun learning experience ever. I really enjoyed teaching this, designing and teaching this class. And this is just to let you know, I've done like 100 of these projects. So mostly in Africa and some in Latin America, not many, and then a bit more in South Asia, mostly India and Bangladesh and Nepal. So that was a pretty great learning experience, because I went to almost every site with my students and really wrestled with really interesting real world problems directly with them, coming up with solutions. Here are a few examples. So at LV Prasad Eye Institute, so this was a patient flow project. I realize my format is not great. This was a patient flow project. A lot of our projects end up being process improvement. But can we reduce loss to follow-up and increase attendance rates at post-op appointments? And what are the methods, and how do we make the clinic visit or the hospital visit better, but also how do we make sure they're keeping their appointments? That's a huge challenge in healthcare across the world. In Kenya, we worked with Ampath, a very inspiring nonprofit, to link to the Kenyan national health system by creating some kind of new product that would bring people information right when they needed it for emergency care. And I can describe that in more detail, but it was a combination of understanding the needs of the users and the interface with the health system and the orchestration and relationship with Ampath. Complicated, but really, really rewarding. For a New York-based company, the project was in Zambia. These guys had invented they're also interesting, but they had invented a anesthesia machine that you could switch to hand power, and that would even concentrate room air to if you ran out of oxygen. So now we can do surgery without ketamine, with proper anesthesia in a remote place. And they came up with a good engineering design, but I spent several years focusing on maintenance and making sure that, like, what is going wrong? Our people, they had designed it to be user serviceable. My students discovered users didn't know that. It was fascinating, really, really interesting. In fact, that company hired at least 2 of my students, maybe 3. So that's also, anyway. All right, now I'm pulling back to the big picture. So I'm using this prepare, act, reflect at these multiple levels. And I'm using the fact that the students are super eager for these projects. In my case, they are very adventurous projects. You might be living without electricity for a month, or 10 kilometers from the nearest paved road. Like, some of them are really, really challenging. They want that. They really want to do something meaningful and exciting and different. And I use that to say, look, the reason you're doing this is because you have learned the disciplines, the theories, and the tools, and you are agreeing to plan and hypothesize ahead of time. This isn't just a trip. You're spending months doing that. When you go there, I want to see you gathering data and applying knowledge and doing implementation tests right away. And when you come back, you must figure out what this means for you. Learn from the experience, close the loop, document, but also if you've discovered that I don't know that what you learned in your class on pricing didn't actually work in Namibia, then maybe you can go and do an independent study or take another class or dig into that some more so that you can deepen your knowledge of the domain. So I was also trying to get them to link what they had learned and appreciate that they had tested some of that disciplinary and framework knowledge to its limits, and then to be curious about what would come next. So I didn't want to do this as a capstone. I wanted to do it in a way that where students could actually take another class afterwards if they were motivated. That was my fantasy. It happened a bit. It did, but it was pretty hard to reshape an MBA slate of courses by and large. But I did, several students change their career goals and careers. Okay, here's my summary, which I haven't argued all the details for this, but this will make sense to you. This is based on a massive reading of the literature. If you want to learn, you've got to iterate. Those iterations need to involve control from the learner. They get to choose what to do. There needs to be quick and direct feedback on outcome of performance. In order for that to make sense, there need to be clear criteria against which they are judging performance. And also, maybe even more important, you need to be encouraged to lay out your prior beliefs, your assumptions, which is hard to do because you don't know what your assumptions are because they're assumptions. So teasing that out a bit. Ideally, they're equipped with the several different ways to test, probe, and examine when they're doing an iteration. We talked about meaningfulness. There needs to be enough psychological safety that the learner does not feel physically at risk too. And psychologically, they need to feel supported to do something they might fail at or that would be difficult or where they don't know everything. What we often neglect in designing learning experiences is there needs to be time to process. And along with feedback, we also need general guidance on methods and directions for converging on a solution, because that is one of the hardest things to do, where I think the instructor is really, really helpful in nudging along towards convergence, especially when you have a bunch of PhDs on a given team, because those students often want to study it forever. And that's it. So I've laid out, I think at a fast clip, some of my own experience, some of the frameworks coming from industry, like the education accreditation industry, and some really specific examples that I am most happy to talk about.
Anjali, thank you very much for the very inspiring talk. I think you brought a lot of very practical examples, very inspiring examples. So those were really amazing. Congratulations for your talk. So thank you again for the lecture. Now we will move on to the second part with discussion of the topic presented by Professor Anjali. So please, those interested in making questions, put them in the chat. We already have some questions, Anjali. I will start with the first one, a question made by André Gomes Barros. His question is, the true test of intelligence is not how much we know how to do, but how we behave when we don't know what to do. So how do you classify the tests to assess intelligence? There
Yes.
are like tests.
Mm, mm. Yeah, that's a really interesting question. The way that quote was framed it was not leading to a literal test in that sense. It was simply saying, if you think you're smart, maybe you're not. You're only smart if you can handle novel challenges. But, if I think about what I wanted to do was to create extreme challenges for my students here at MIT, like as extreme as I could go. Actually, so extreme I was sometimes very stressed. But I think it was an attempt to do exactly that. And rather than using it to assess or evaluate, I was using the extreme challenge as a challenge for students to rise to the occasion, right? So this was my theory was, sure, we could assess people by looking at their ability to handle novel situations, and I have a asterisk on that. But can we use that same idea to really cultivate the passion for learning by doing and learning with others and serving others? Like, I had all these other really big goals. And if I can get them to feel this is a test of their intelligence and then they deliver, it is awesome. Like, they are then ready. They're going to be contributors their whole lives. They care about these people. They care about the places they went. So for me, that was a really good outcome. I want to make one other point. There is research. There are findings from the educational research literature on the extreme difficulty in classroom learning, in particular, of having learners who think they have mastered a construct apply it to a novel situation. And I've even done some experimental work on this. My background is in simulation modeling, and we would have two versions of a same system, but with different cover stories and time constants, but the same system. One example was commercial real estate, and the second was supertanker construction. They both have a production lag and hence a boom and bust cycle, right? It's just a bullwhip kind of effect. But we would teach people on one and test them on the other. And often they were not porting over the structural knowledge. They were not. They had the surface, but not the deep. But I think that's a problem in all kinds of learning. Like the ability to step back and have a structural insight, something about relationships, something rather than a story insight or a detail cover story insight. That is a hard goal that we all take on every day. One final point I make on this, my attempt to have them articulate what they're learning is trying to do this a little bit, saying, here's what you thought at the beginning, here's what you think at midpoint, here's what you think at the end. Like, account for that in a way that not only tells a story about your own learning, but makes you conscious about how you and others learn from experience, so that you can be a better manager, better parent. Okay, that's a long answer. Thank you for that question.
Well, it was excellent, very, very interesting. We have another question here from Anderson dos Santos Viana Jr. He's asking about the teams and how are the teams, graduate or undergraduate students?
Yeah. So across MIT, we actually do a wide variety of different experiences and efforts like this. When you are giving degree credit, it becomes really important to make sure you're setting up the students for success, right? Because their graduation relies on this. When you're doing it as extracurricular or as an option, which we have tons of across MIT, we're a little more flexible on those aspects. But for degree credit courses, we tend to design for one or the other. We tend to design for undergraduate and for graduate. I personally did not want to send undergraduates into relatively high risk, complex situations. So I work only with graduate students. But D-Lab, another program at MIT, sends undergraduates. They sort of go in a group, but there are programs that work directly with undergraduates. And if you teach undergraduates, one of my all-time favorite MIT programs for undergraduates is first semester, first year Terrascope, where they just like jump in and go somewhere and try to figure things out. But I'll send a link to that because it's really cool. Okay.
Mhm. So, and our related questions. What about the mixed teams with
Yeah.
undergrad and grad students? I mean, like different levels and with different
Yeah.
perspective, not
Yeah.
professionally from life
Yeah.
experience.
Yeah. Yeah. So again, in this travel class, I didn't mix them, but in my other class, I do. And it's I like I like diversity, including age diversity. There are a lot of preconceptions different people bring to bear. Like a team of 4 grad students, when they get one undergrad, they're like offended. But here at MIT, everybody knows the undergrads are smarter than the grads. Like it's just common. So I'd always just say that. But what I've learned is also that it's really interesting because I also draw PhD students, but they usually go straight through. But our MBAs have at least usually 5-6 years work experience. So that it's always interesting to see that mix. Like the straight through student who's maybe 24, really, really smart and learned, not worldly, and then somebody who's been in industry for 6 years. How do they work together? That's always interesting to see. So there's that kind of diversity. I do, it's a big problem. It's a big challenge to figure out how you should assign students to teams. We can talk about that next if you want to, but it's really, we've tried many different ways. Nothing's
Okay.
perfect.
Mhm. With all your experience and of collaborations of different types, and what do you think is the biggest challenge for an effective learning?
I think here's what I learned. I did exit interviews for several years with my students because this class is very expensive, right? I have to pay airfare for at least 70 trips a year to Africa or whatever. Like I'm doing a lot, and it's carbon cost as well as money cost and time cost. So are we getting what we want out of it? And my exit interviews with students, they would often, this was so interesting. They would often say, "Oh yeah, I did this really cool thing." They could describe it. But then I would say, "How did you learn how to do that?" And they would say, "I knew it all along." And it is not true. So I tried another approach of giving sort of mini tests at the beginning, but I couldn't. Those tests did not match up to the content of the projects well enough to be indicative. Then I tried another experiment because I had been watching MTV Real World, where they talk straight to the camera. I mean, a lot of reality TV does this. What they're thinking, right? What's your current hypothesis? So that was my next idea: is every week, every person speaks to camera. Here's how my thinking is. No, they only were self-serving. All of those reports on their current hypotheses and mental models were almost all of them were, "Professor Sastry, I'm working really, really hard." Like I'm a really good person working really, really hard. So it's like, okay, it's disclosing your mental model is not that easy. So then I tried like a fifth thing, which was ask them a question or two every Monday, require that. And then sometimes I work with them for 6 months, like put them all together after 6 months. You have a lot of observations, and you will see that you thought differently at the beginning of this course. And I would print them out in little booklets for each student to say, here's your journey. Here's where you were in November and December. Here's where you were in January and then February and then March. So that's kind of that proved to be effective because self-reports, because learning from lived experience is often so quickly integrated into one's self-conception that it feels like it's there forever. You quickly draw, especially if it's a vivid and influential learning experience. It's not like I learned how to do double entry bookkeeping. It's like I went there and solved a real challenge. The human tendency is to say that's me, or I knew it all along, or it's common sense, not thanks to what I learned and how my professor helped me. So that's one of the sad realities, but it's okay. There's a huge trade-off because they do actually learn. You just don't always get the credit.
Yeah,
Yeah.
that's really, really true. We're getting here close to the end. One more question about the ABET or related to ABET, about continued improvement by the university in terms of the outcomes and how is it the continued improvement at MIT in terms of ABET?
You know, it's a really interesting question because I think it's a weak area for us here on the faculty at MIT. My first faculty job was at the University of Michigan, where there was a real investment in a collegial, team-wide faculty group giving each other feedback. Maybe it's also the difference between being junior and not. Here at MIT, there's huge amounts of ongoing improvement. A little bit of it is driven by just straight up competition and and ideation at the individual level. We do have some interesting collaborations, so joint teaching, joint collaborations across departments and schools, and that's a nice vehicle for learning from each other and for improving. But yeah, ABET requires continuous improvement. And the story I just told you about tracking learning is one example of how I tried to do it, like 4 different times. But like, how do you, like, what are the mechanisms, and does your institution support this incremental step-by-step improvement in the design, the aspects of the teaching and learning, and then in the understanding of the learning? Because as you saw from those ABET definitions, engineering design and tackling complex engineering challenges are really big, complex domains with many choice points and many factors. It's pretty hard to, like, you can't get it right, and it's even hard to, you have to take seriously where your focus is going to be and what your trade-offs are. And it's, some classes might focus on one versus another. Like, being able to kind of wrestle with that complexity, I think, is really needed.
Excellent. Um, Professor Angeli, we are wrapping up here and the activity. It was a really very enriching discussion and your presentation. Like, we learned really a lot. Uh, Professor Angeli, we sincerely thank you for your participation in our event. It was a pleasure having you here. People in the chat, they are registering that, like, it was very nice having you in the event. It was very helpful with a lot of practical examples and a lot of insights. So thank you for that. And
Good.
to everyone watching, thank you for being here, and we hope you are enjoying the event.
Thank you, everybody. Pleasure. Good luck
Thank you
in all
very
your
much.
new ventures. Okay. Cool.
See you.
Thanks. Bye.